All right, so we're going to look at the second part of unit circle trig. What I want to do though is let's go back through the definitions in the first part because we need those again. Just make sure we remember what they are. All right, so what are the names of the first three trig functions that we wrote down? And they were on the left-hand side. Yeah. So sine, cosine, tangent. And then inside those parentheses, remember that's called the argument. There's no multiplication. So when you write something like this, there's no multiplication in that problem at all. It's just saying this is the number that we're filling into this function. Right? It's kind of like when I said yesterday, if I said to you, what's the square root? And I said, well, what's the answer? Square root. Well, there is no answer because you didn't plug in a number to take the square root of. Right? It's the same idea with sine. If you just write sine and you don't put anything, you can't answer that question because you haven't told me what you want to take the sine of. Like what number do you want to fill into the formula? Right? And the number that we fill in is always an angle. It can be in radians or it can be in degrees. Now, if they give you the angle, that's fine. But the angle isn't the most useful thing that you need. What is it that you really need when you do unit circle trig? Coordinates. Right. Not the angle. You need the location of the angle. Right. And we talked about how to find the location for 4 points yesterday. 0, 90, 180, and 270. Right. And we'll write those down in a second. So again, here, usually they use a Greek letter. Theta. Most commonly used. And what are the names of the next three trig functions going down on the right side?
Cosecant.
Cosecant.
Secant.
Secant.
And it's COT. I forget what the name is.
Anybody remember the name?
Cotangent.
Cotangent. Yep. Okay. And again, if you just write those three things like that, you haven't really written anything down. You've written part of what you need. It's like a square root symbol without a number. You've got to put a number into the function. Again, what number are you putting in? Well, whatever they tell you. Yesterday I gave you different examples of the quadrantal angles. So that's what we filled in yesterday. Now, if they don't give you the angle, then I got to give you something. Then I'm going to give you a coordinate. Coordinate has two values in it. Has an x and a y. And each one of those definitions uses either one or both of those letters in the formula. Let's start with sine. What was the definition of sine? Yep, sine was the y value. How about cosine? It's x. And Jaden, how about the tangent?
Y over x.
Y over x. Yep. So once you find your coordinate for the point on the circle, you're going to fill in, if you're doing one of those three, either the y, the x, or y divided by x. All right. Now, once we know the first three, there's a connection to the three on the right. Does anybody remember what the connection is?
Reciprocals.
Yep, it's the reciprocal. So if we did cosecant, Madison, what would the cosecant be for the formula?
1 over y.
Right, it's 1 over y. Okay, and Ruben, the secant?
1 over x.
1 over x. All right, and Kent, the cotangent?
X over y.
X over y. So those are the definitions of the 6 trig functions if you know the coordinate on the circle. If you don't know the coordinate, you can't do this. Okay, so you've got to figure out the coordinate. So when we talked about the coordinates, there were 4 that we did yesterday. And those coordinates go with these 4 angles. Okay. first of all, what kind of circle is this? I said that we could use any circle, but if we use the one that I talked about yesterday, it just makes the arithmetic easier. Yes, this is a unit circle. And what does it mean if a circle is a unit circle?
Radius of 1.
Right, it's a radius of 1. So Lucas, what's the coordinate for the point that's at 0 degrees?
1, 0.
Yep, this is 1, 0. So if you have to do anything with a 0-degree angle, this is the x value you use, this is the y value you use, and then you fill those two numbers into whatever formula they want you to find. We generally practice all 6. Some of the questions towards the end of the homework only had you do 1. All right, the next coordinate, 90 degrees. Holly, do you remember the coordinate for 90 degrees?
Was it 1, 0?
So 1, 0, that's the coordinate
Oh,
for
sorry.
0 degrees.
0, 1.
0, 1. Yep. Okay. And the coordinate for 180. Quinn?
Negative 1, 0.
Negative 1, 0. And Jaden, the coordinate for 270.
0, negative 1.
0, negative 1. Okay, those are the 4 easiest coordinates to work with. Those are the easiest ones we're going to have all week because they only have 1, 0s and negative 1s, so the arithmetic is pretty easy. What kind of numbers did we see yesterday that came up that made some of the arithmetic a little bit more complicated, especially some of the fraction ones?
Square roots.
Right, we can have square roots, okay, and we're going to see more of that today. So if we ended up with something like that, is that answer okay to leave as like the final answer? No, because we have a square root in the bottom, so we always have to fix having square roots in the bottom. We do that by multiplying, and what would we multiply by top and bottom to fix that?
So
Square
square root 3.
root of 3. So square root of 3, square root of 3, and now you go straight across. 1 times the square root of 3. And then in the bottom, the square root of 3 times the square root of 3 is the square root of 9. And the square root of 9 is 3. So instead of writing what's in the box, you have to write it as what I circled. The other thing that can happen with square roots is sometimes we need to reduce them. So let's say we had the square root of 12. Different ways you can reduce it. I generally try to find 2 numbers that multiply to give me 12, and one of them has to be a number I can take a square root of nicely. So what 2 numbers multiply to give you 12, and you can take the square root of one of them? 4 and 3. So we break it up like that. 6 times 2 wouldn't be a good way to do it, because you can't take the square root of 6 and 2 and get an answer without decimals. But square root of 4 you can. There you go. So that's the square root of 12. 2 square roots of 3. Okay, so that pretty much reviews everything that we learned yesterday, minus doing all the examples again. So, what we're going to look at today is finding the trig functions of 30 degrees, 45 degrees, and 60 degrees. Okay, so let's look at where those are on the circle. 30, 45, and 60. All right. First of all, 30, 45, and 60 are all in which quadrant?
First one.
Yes, they're all in the upper right, which is the first quadrant. Where's 45? Right, it's right in the middle. So here's 45. And now, how far away are 30 and 60 from 45?
15.
Yeah, they're each 15 away. So 30 would be about there, and 60 would be about there. Notice they are not 3 points equally spaced in the quadrant. They're all kind of clustered in the middle part. The two that are missing that would make it equally spaced would be one here, which we don't talk about, and one up there. Does anybody know what those two red dots would be?
15 and 75.
Right, it would be the 15 and the 75. Okay. You can do the 15 and the 75, but in this class, it's just we don't get to those. Okay. So we're going to do the 30, the 45, and the 60. All right. So the goal is to figure out the coordinates for those three. Once we know the coordinate, everything else we've done is exactly the same. What do you know about the x and the y value for the coordinate of 60, 45, and 30?
Positive.
Yeah, they're both going to be positive. Okay, everything we're doing today is in quadrant 1. So your x and your y values are positive. Okay. All right, let's start with the 45. Okay. So let me draw just the 45. Let me try to draw a relatively nice picture. Let's go like this. Okay, so 45 is right in the middle. To figure out the coordinate, we have to figure out two things, the x and the y. The x is how far to the right that you go. I'd say that's about right there. Okay. We're going to go this far to the right. Now, if we went all the way to the right, what's the distance if you go all the way to the right? 1. So we're not quite going 1. We're going a little bit less than 1. And then we're going up this amount. Again, we didn't quite go all the way up. If we had gone all the way up, how far up would we have gone? 1. So we're going to the right and we're going up, but it's a little bit less than 1 in each direction. So those are the two lengths I need to find, but it's going to be a lot easier to find those lengths if I turn this into a shape. Anybody have a guess what shape I'm going to create?
Triangle.
Yep, make a triangle out of that. And the goal now is going to be to work with that triangle and figure out the two sides. This side we already know. How long is that side?
1.
Right, that's 1. Because any line drawn from the center to the edge of a circle is a radius. And all the radii are the same length. So this side is 1. Unfortunately, that's not the coordinate, though. That's if you move at a diagonal. We need to know how far right and up, not diagonal. But we can use the diagonal to help us. So this angle right here is 45 degrees. The reason I know that is because that's the angle I have to tilt the hypotenuse at to make sure it points at 45. So this is a 90. This is a 45. What would the angle at the top be? Hey, it would be another 45. So to figure out the coordinates of 45 degrees, we need to work with a 45, 45, 90 right triangle. Okay, so I've taken the picture that you just had on the other page, and I just made a copy of it bigger off to the side. Besides being a 45, 45, 90, can anybody tell me what other kind of triangle that is?
Right.
Yep, so it is a right triangle. How about anything else about that triangle?
Is it a squared plus b squared equals c squared?
Okay, so we might be able to use that theorem to help us figure some things out in a little bit. But there's something else we need to know about this triangle first. Is there anything else you can tell me about it? Yeah.
Is it the 90-degree angle?
Is does it have to do with the 90-degree angle? Not directly. No, not what I'm thinking of. It has to do with other angles in it, though. Anything else you can tell me about that triangle? It's more than just a right triangle. There's another word you can use to describe it. Yeah? No, it can't be acute and right. So you have to be one or the other. So it's this is definitely a right triangle. Acute would mean you have no 90-degree angles because everything is less than 90. So in this case, not every angle in that triangle is less than 90. We have one that is 90. Any other words coming to mind that can describe that triangle? Well, there's something else about it that's important. It's not trig, it's geometry.
Area of it?
The area of it? No, we don't have to look at anything with area. Sometimes we do loop stuff with area, but no, not in this one. We don't need anything with area. Yeah?
I don't remember which one. Is it scaling or isosceles?
Could be one of those two. Anybody have an idea of which one? Yeah? What does that mean? Oh. Okay. So what, can anybody tell me what those two words mean? Can somebody take a guess at what one of those words means? Yeah?
I can't remember which one it was, but it doesn't have to be like two angles being the same.
Okay, one of them does mean that two angles are the same. Yes. Which word is that?
Isosceles.
Yeah, it's isosceles. I'll take that. Now, it also means something else. If something is an isosceles triangle, it does mean what you just said. It means one other thing. Yeah?
Does it have to do with the long side?
No, it doesn't have to do with the long side.
The two short sides are the same length.
The two short sides are the same length. In an isosceles triangle, those two sides are exactly the same. And the reason we need to know that is because when we set up Pythagorean theorem, which is what a squared plus b squared equals c squared, we need to fill that in correctly. And if we don't know that those sides are the same, we're not going to be able to use that formula. All right, so because they are the same, we don't want to use different letters to represent them. The letters are temporary, but we don't want to use different ones. Using different letters means they are different lengths, and they're not. They're the same length. So temporarily, what do we want to call each of those sides?
X.
X. And now what we want to do is solve for x. Once we solve for x, x is how far over you have to go, which is the same as how far up you have to go. The two numbers in the coordinate for 45 degrees are exactly the same. We just have to figure out what they are. Okay, so if we wanted to set up Pythagorean theorem, can somebody tell me how I would fill in Pythagorean theorem with the three sides in that triangle?
X squared plus x squared equals y squared.
X squared plus x squared equals what?
Or can you 1 squared?
Like, yeah, 1 squared. I have to, because it's the bottom leg squared plus the height squared equals the hypotenuse squared, which is 1. Well, it's 1 squared, but that just comes out to 1. All right, so let's solve that for x. What do we get when we add x squared plus x squared?
X to the 4th? Oh no, 2x squared.
2x squared, right. If you're multiplying, you would get x to the 4th, but we're adding. So 2x squared and 1 squared. All right, so we got that. 2 steps left. What would be our next step to get x by itself?
Divide.
Yep, divide, and what would I divide by, Lucas?
2.
2. So divide each side by 2. Okay. Is x by itself? No. X is being squared. We don't want to know x squared, we want to know x. So what am I going to do to get rid of squaring? I have to square root. And when you square root the left, you also have to square root the right. And the way you square root a fraction, you do the top and you do the bottom. That's how you square root a fraction. So what happens on the left?
Just X.
It's just x. Square and square root cancel. And now let's simplify what we can here. The top is good. What's the square root of 1? 1. Now, can you take the square root of the bottom and get a nice answer? No. Then we have to leave it as square root of 2, but what's wrong with that? Right, we don't want to leave the square root in the bottom. So this now goes back to what we did yesterday. We have to fix that. What do we multiply by to fix it? And when I multiply straight across, what will I get for a fraction?
1 square root of 2 over 2.
Yep, 1 square root of 2, which is just square root of 2 over 2. Now remember, we said that we weren't quite moving 1 unit over. If we moved to here, this would be 1 unit. We only went to here. So how far over did we move? We moved square root of 2 over 2, which I'll show you how much that is in 1 second. Okay, so we type in square root of 2 divided by 2. Oops. Let's try again. Square root of 2 divided by 2 comes out to 0.7 roughly, which is a little bit less than 1. Okay, as far as knowing that decimal, we're not really going to have to know it. We don't use it. We're always going to leave the answer as square root of 2 over 2. Because if you write 0.7, that's rounded. That's not as accurate. Okay. So, now we know the length of the bottom side. We know the height of the triangle. So what would be the coordinate for 45 degrees?
Square root of 2 over 2 for X and square root of 2 over 2 for Y.
Yep, square root of 2 over 2. Square root of 2 over 2. So now that we know that coordinate, if we forget it, we could go back and figure it out again. But I'd rather not have to go through and do all that again. So now we just have to know the coordinate for 45 degrees is root 2 over 2, comma root 2 over 2. And that's the reason why. So it's based on the Pythagorean theorem. And that's a number, if you remember, you saw this yesterday. Root 2 over 2 was something we did, and I said, you don't need to know what this is the coordinate for, but you will tomorrow. Now you know. It's the coordinate for 45 degrees. All right. So let's try finding the 6 trig functions of 45 degrees. Okay. When you are doing unit circle trig, what is it that you ultimately need to have to be able to do it? Right, you need to be able to have a coordinate. In this problem, the way it's written, did they give you a coordinate? No, they gave you an angle. What you need is the location of the angle. So the hope is we just remember what 45 is. Okay, so what is the coordinate for 45 degrees?
Square root of 2 over 2, square root of 2.
Yep, square root of 2 over 2. Square root of 2 over 2. That is the coordinate for 45 degrees. Now, once you know the coordinate, everything we do is exactly the same as what we did yesterday. And I think we did a problem, if not the same question already, we did one extremely similar to it yesterday. All right, so let's start with the sign. Okay. Because they're the same, I want to make sure we get the right one so you know which one is which. The sign is which value again?
Y.
It's the y. If you mix the x and the y up this time, you would be okay. But in general, they're not always the same. Okay. So sine is the y. What's the cosine of 45 degrees?
X.
X. And the tangent is when we divide the two. What's y divided by x? 1. Okay. We don't have to do any fancy arithmetic to figure it out because we're dividing two things that are the same. So we get 1. Now, once we have the 3 that are on the left, what do we do to get the 3 on the right. Great. You just take each one of these, and we're going to flip them. Okay. So what would be our first step to get the cosecant of 45?
Flip it and multiply by 2 square root 2 over 2.
Okay, so we're going to flip it. So that's the first step. Flip the sign, and then multiply to fix the root in the bottom. And does anyone remember what we get when we do that? Right. I think we did that yesterday. Just get square root of 2. Because you get 2 times the square root of 2 divided by 2. And it reduces to that. How about the secant? Right. The sine and the cosine were the same. So that means the cosecant and the secant are the same. So square root of 2. And lastly, the cotangent. 1. Okay, so when you are doing the unit circle trig, we won't ever be using decimals. All your answers for any angle that's a multiple of 45 are going to look something like this. Okay. Any questions on that? So now, if I had, say, something like this, here's 90, here's 180. What if I put the angle right in the middle of that quadrant? Anybody know what number that would be?
It would just be negative square root 2 over 2.
So I'm going to get to that in 1 second, but do you know what angle it would be?
135.
This would be 135. 135 is almost the same thing as 45. There's your triangle for 45. Here would be your triangle for 135. What's the connection between these two triangles? It's just flipped. So when we do 135, it's a mirror image of 45. So when you mirror image something, does that change the length of anything?
No.
No. This side is still root 2 over 2. This side is still root 2 over 2. But the difference is we're going left and up. So what happens when you go left and up versus right and up?
You put a negative.
You put a negative on the,
X.
right, you put a negative on the x. So now if you wrote down negative root 2 over 2, comma, positive root 2 over 2, you could do exactly the same problem for 135. Okay, I'm not going to get into it more than that today. That'll be more for tomorrow. You could also do this one down here, and you could do this one over there. Those are all the different 45s. 45, 135, 225, and 315. And the key is knowing the first one. And that pretty much tells you everything you need. Okay, so the ones we're learning today are very important because we're going to use them in every other quadrant tomorrow. Okay, any question on the 45? All right, so the last one we're going to look at is the 30s and the 60s. All right. So we already worked with the 45, 45, 90. That's done. We can forget about 45, 45, 90 for now. 45, 45, 90 is only going to help you if your angle is a multiple of 45. If it's a multiple of 30, then it's a different problem. So let's put 30. How many degrees are there altogether in the first quadrant? Right, it goes up to 90. We're at 30. Okay, that's about a third of the way. And again, the goal is to figure out how far over you go, and then how far up you go. This is your x. This is your y. On the x, did we go all the way over to the edge of the circle?
No.
Not quite. We did go over a little bit further than the 45 though. Okay, 45 would be about here. It would have come down to about there. 30, you're a little bit further over. Did we go all the way up on the y? No. We went up even less than the 45. So again, what shape do you think we're going to make out of this one? We're going to make a triangle out of it. This angle right here is your 30, because that's the angle between the bottom and the hypotenuse, so that it's tilted and pointing at the 30. So I'm drawing the same diagram off to the side a little bit bigger, but maybe I should ask how I know this.
Everything in the triangle is 180.
Right. If I know the bottom is a 90 and a 30, then this one has to add up to 180 with the other two. Yep. Okay, so next step. Are there any sides in that triangle that we already know? This one off to the side. The hypotenuse is 1, right? Any line from the center to the edge is a radius. Unfortunately, that's not the x or the y. That's a diagonal. What do we know about the sides this time?
Very different.
Yeah, they're all different. Right? Anybody know the name of the triangle where all the sides are different?
Isosceles. Or
Well, no, that was the last one.
what was the other one they said?
Scalene.
Scalene, yeah. Scalene is the kind of triangle we have this time. Every side is a different length. So if we were going to try to use Pythagorean theorem right now, just watch this though. Okay, just watch what I'm doing. Don't write this part down here. We'd have to use 2 different letters because they're 2 different sides. And if I wanted to set up Pythagorean theorem with this, what would the Pythagorean theorem look like?
X squared plus y squared
X squared plus y squared
equals
equals 1 squared. That's a problem. That's not good. Why do I think there's a problem here?
Just doesn't work.
Why? That Pythagorean theorem equation is very different than the last one.
Yeah, because there's an x and a y.
It's an x and a y. The problem is you have 2 different variables. If you have one equation you're trying to solve, which we do, we have one equation, but you have 2 different letters in the equation, that's not going to work. Right? We're not going to be able to solve it with 2 different letters. It doesn't mean we can't use Pythagorean theorem. But what it does mean is you've got to figure out one of these other letters in a different way before you use the theorem. Okay, you've got to find some way to figure out x or y. Okay. Anybody know how you could figure out the x or the y without, can't use Pythagorean theorem?
There's some rule for 30, 60, 30.
There is a rule for 30, 60, 90, and if you know the rule, we could use it. Anybody know the rule? All right, so we can't use the rule then. So we gotta come up with some other way. I'm gonna go like this. I'm not gonna give it to you completely. I'm just gonna give you a hint. Okay, that's my hand. Any thoughts? So this was my hard question for today. Not, hope we got the other ones eventually, but this one is I thought the hard one. So any thoughts what we do with that? All right, well, what did I just do?
Wrote it twice.
Yeah, I made a copy of it. So why do you think I made a copy of it? Not just for the fun of it. Probably going to do something with that copy.
Make it a rectangle.
Make it a rectangle? Okay. How would I make it a rectangle?
Flip it
Flip it? I would have to flip it.
upside down.
I gotta flip it twice actually. Okay. So we've got a 90, a 90, a 90, and a 90. So we have 4 90-degree angles. Opposite sides are congruent to each other. Yep, that's definitely a rectangle. Yep, sure is.
I don't know what that does for us, but that's all I had.
Yeah, I'm not sure what that does for us exactly, but I like the way you're starting to think. I'm not sure what we would do with that rectangle. Any other suggestions? Kind of along the same idea, maybe, that we just tried.
Flip it again, make a bigger triangle?
Make a bigger
I
triangle.
don't know.
Okay. How would I flip it to make a bigger triangle?
Flip it over the y-axis.
Flip it over the y-axis. Okay. So you want to flip it and do that. All right. It does make a bigger triangle doing it that way. I'm not 100% sure if we could do anything with that. So there's one more thing we could try, and that I do know how to do something with. What else could we try?
You're making another shape?
Yeah. There's one other way I can do that I haven't done yet.
Make more copies and make it a diamond.
No, we're just going to use those 2 copies. No more copies. No, not any more complicated than 2. But there is something else I could still do that we haven't tried.
Put the X's face to face.
Okay. What are you trying to make?
Another big triangle.
Okay.
Like,
How would I do that?
I guess
Flip it.
Flip it on the x-axis.
Yeah, so flip it like that.
Yeah.
Oh, you gotta flip the y? Or
No, just like that.
Like
Yeah.
that.
Yeah.
Okay. What have I got there now?
Oh, now you got 60, 60, 60.
Right, now I just created an equilateral triangle. This is 60, this is 60, this is 60. What do you know besides all the angles are 60 in an equilateral triangle? I just told you that. What else do you know in an equilateral triangle?
Everything's equal, all sides are equal.
All the sides are equal. That means this side is 1, this side is 1, but more importantly, this side is 1. Okay? And what else do we know about the top part and the bottom part of the equilateral triangle? Yeah, what?
What'd you say?
What do we know about the top part of the equilateral triangle, this one, and the bottom part?
Oh, they're the same.
What's the same?
Everything.
Everything. Okay. Can you tell me,
Half of it.
what does everything mean? Can you be more specific?
All the side lengths, all the angle
Right.
measurements.
So like this side is the same as this side, that side is the same as itself, that side is the same as that side. Everything's the same, just flipped. So that should kind of tell us one of those letters.
Yeah, y is half.
Y has to be a half. Because it's 2 sides that are equal, and they have to add up to 1, so that proves y is a half. We just found one of the other sides a different way. Now we can use Pythagorean theorem, because we're only missing one side.
So what's the rule?
What's that?
What's the 30, 60, 90 rule?
I'll show you once we finish the other side. So we still don't know this bottom side. We don't need this this bottom triangle anymore. We could keep it there, but I'm just gonna move it off. So we're just gonna focus on what we have right there. Oops. Make this X. Well, one thing I can tell you now is the short side is always half the hypotenuse in a 30, 60, 90. So if the hypotenuse was 10, the short side would be 5. What we still don't know is the bottom side. But we can set up Pythagorean theorem now to get the bottom side. What would the Pythagorean theorem look like now, filling in what we just found out about y?
X squared plus half squared equals 1/3.
X squared plus a half squared equals 1 squared. What's half squared? Quarter, yep. That's a quarter. And our next step to get x squared by itself is to move the 1/4 to the other side. What's 1 minus a quarter? 3/4. Okay, so we almost have the bottom side. We just need to do one more thing.
Square root.
Take the square root. And when we square root, remember you do the top and the bottom. Can we take the square root of 3
No.
and get a nice number?
No.
No. So we're going to leave that. Can we take the square root of 4 and get a nice number?
Yes.
Yeah, 2. So now we know the bottom side is the square root of 3 over 2. I think the rule is the bottom side ends up being this side times the square root of 3. So if you multiply this by square root of 3, you'd have square root of 3 over 2. We don't really need to know that rule for this because we have the coordinate now. We figured it out. So we're not going to have to go back to that rule to figure it out ever again. All right. So here's the 30. So how long is the bottom side?
Square root of 3 over 2.
That's what we just solved for, square root of 3 over 2. And how tall is the triangle? 1/2. Yep. So that is the coordinate for 30 degrees. It's always square root of 3 over 2, comma, 1/2. Okay, now we figured it out. We know it. We don't want to have to go back and figure it out again. Now that you know the trick, it's not really that hard. You just make 2 copies and it's kind of a visual just little trick to help you figure it out. Now the other thing is just to make sure we know which number is bigger. Do you think the square root of 3 over 2 is bigger? Or do you think the 0.5 is bigger?
Square root of 3 over 2.
Yeah, and hopefully you can tell by my diagram. The bottom side is bigger than the height. Square root of 3 over 2 is about 0.87. Again, we'll never round it, but that's about what it is. And the height is 0.5. And if you forget which number goes where, think of your triangle. Which angle is bigger, 30 or 60? 60 is bigger. That means the bigger side goes across from the bigger angle. The smaller side always goes across from the smaller angle. Okay, so 1/2 will always be opposite 30, and root 3 over 2 will always be opposite 60. No matter which way you draw your triangle, even when we put it over here tomorrow. This is the short side, this is the long side. All right, so that's the 30. Now we're going to do it all over again for 60. So here's 60 way up here.
Why not just flip it?
All right. So what do you think about the 60?
Why can't you just flip the x and y values?
Yeah, that's all that happens when you do the 60. We don't have to do it all. It's the same triangle. This is the 30. The 30 is now up at the top, and the 60 is down here at the bottom. So what happens is the 30 and the 60 switch places, which means these two numbers switch places. So what's the coordinate for 60?
1/2, and then the y is square root of 3 over 2.
Yep. So those two coordinates right here, for the 30 and the 60, and the coordinate that we did right here for the 45, those are the only 3 coordinates you need to know. And we're going to be able to do everything we need anywhere we want on this circle. Everything else is just mirror images of what we've done. Okay, so any questions on the coordinate for the 30 and the 60? Okay, all really is just from the Pythagorean theorem. Every coordinate we did today. All right, so let's try this one. Find the 6 trig functions of pi over 6. Okay, what have they given me to do this problem?
Radian.
They've given me something in radians. What does that represent though?
Your angle.
That's my angle, yes. They gave me an angle. Is that helpful directly for the unit circle? No, the angle isn't what you want. What you really want is the what?
The coordinates.
You want the coordinate. If you're not sure what the coordinate for pi over 6 is, then you're going to have to write pi over 6 in a way that's easier for you to determine that. Pi over 6 is in radians. How would we change that 2 degrees?
30 degrees.
Yeah, it would be 30 degrees. Is there any question on how you change it to 30? Multiply by 180 and divide by pi. Okay. So great. We know it's 30. That's still not what we need, but hopefully it's easier to figure out what you need now. What is the coordinate? Well, if you're not sure what the coordinate is, you know it's going to involve 2 numbers. There's a root 3 over 2 and there's a 1/2. Okay. You have to get the order correct. If you can't figure out the order, draw a picture. Doesn't have to be perfect. Just try to make it somewhat accurate. Put 30 right here. Make a triangle. If you draw it somewhat reasonable, you should be able to tell which side is the short side and which side is the long side. The long side in the 30, 60, 90 is always what number? What number?
Square root of 3 over 2.
Yeah. And the short side is what number? 1/2. So now by drawing the diagram, I can tell x is root 3 over 2 and y is 1/2. So that's my coordinate. Root 3 over 2, 1/2. Now we got the coordinate, we can write down all 6 trig functions. All right, let's start with the sign. Christian, what's the sign of pi over 6? 1/2. Okay, Quinn, what's the cosine?
Square root of 3 over 2.
Square root of 3 over 2. And Madison, how am I going to find the tangent?
1/2 divided by the square root of 3 over 2.
So we got 1/2 divided by the square root of 3 over 2. And can you tell me how I would simplify that?
Square root of 3 over 2.
Not sure. When you have a fraction divided by a fraction, do you remember? I think there was a rule that Lucas mentioned yesterday. Yep. So how can you explain to me how that works in this problem?
1/2
Yep.
times 2 over square root of 3.
2 over square root of 3. Now the 2's are going to cancel, so we're left with 1 over the square root of 3. Can anybody fix that and tell me what it would be if the square root was not in the bottom?
Square root of 3 over 3.
Right. It would be square root of 3 over 3. Okay, so that's your tangent. How about, let's see, Jaden, what's the cosecant?
It's 1 over 2, or 2.
2, yep. So it's 2. Holly, how am I going to get the secant?
Is it 2 over the square root of 3?
Yep. So we're going to start with 2 over the square root of 3. And can someone else tell me how we fix that? Yep.
Multiply by square root of 3.
Yeah. multiply top and bottom by square root of 3, and you get 2 root 3 over 3. Right, and now the cotangent. Now, if we're clever, we can make sure we do this pretty quick. We have two expressions that are equal to each other. What's in the purple box and what's in the black circle. They are the same thing. Which one of those should I flip to get the cotangent? Yeah, why flip the first one?
This just gives you square root of 3.
Right, if you flip the first one, you get the square root of 3 in the top, and you are done. If you flip the second one, the square root goes back to the bottom again. You've got to fix the whole thing again just to get the same answer we just got. Right. Any questions on the 6 trig functions of 30? Okay. And the last one is the 6 trig functions of 60. Okay. So you tell me, what's the first thing we need to do? Get the coordinate. Yep. Okay. What is the coordinate for 60 degrees?
Half over square root or half square root of 3 over 2.
Yep. So 1/2, and then square root 3 over 2. And we're going to get very similar answers to what we just got when we did 30, because we're using the same two numbers. They're just switched. So what's the sign going to be?
Square root of 3 over 2.
That's going to be root 3 over 2. Ruben, how about the cosine?
1/2.
Yep, it's going to be 1/2. And Lucas, could you tell me how I get my tangent?
Square root of 3 divided by 2 over 1/2.
Over 1/2. Okay, and what's going to happen there?
We do square root of 3 divided by 2 times 2 over 1.
Times 2 over 1. And what does that leave you with?
Square root of 3.
Square root of 3. So we're not getting any new answers. These are all answers you had in the other problem. They're just in different spots. Okay. What about the cosecant?
2 square root of 3 over 3.
It's going to be 2 square root 3 over 3. Okay. What about the secant? 2. And what about the cotangent?
Square root of 3 over 3.
Square root of 3 over 3. So if I put a box around, which ones changed places? Those two changed places between the problem on the left and the right. These two changed places. And those two changed places. Those are the answers that switched between the left and the right problem. And if you read the trig functions that are in each box, sine, cosine, secant, cosecant, tangent, cotangent. The ones that switched places are the trig functions you get when you put the word co in the front of it. Secant, cosecant, sine, cosine, tangent, cotangent. All right, and we'll talk more about what those are called later on. Any questions on 6 trig functions of 60? Okay. So the homework for tonight, it is a worksheet. I'll pull it up, make sure people know where it is. There's 10 questions on the worksheet, and then there's 5 additional questions that are not. Some of these questions review stuff from yesterday, some are from today. Okay, so you'll need to copy those 5 down.